Hi everyone, it's Math with AUB. Let's prepare ourselves for set. Our question number 10 reads as kinetic energy K or KE is calculated by the universal formula 1 over 2 half mv square, where m is the mass, v is the velocity. We are asked to find what is the velocity. We are asked to find v in terms of m and k. We are asked to find v in terms of m and k, or one can say simply solve for v, or make v subject, or find v in terms of kinetic energy and mass. All they are same phrases for finding the value of v. Some literature says that solve for v, make v subject, or write v in terms of kinetic energy and mass. We have kinetic energy, that's k, is equal to 1 over 2 half times mv square, half times mv square. We are asked to find v, taking 2 here from right to left, from division to multiplication, it will become 2 times k is equal to 1 times mv square. We are interested in finding the value of v. Shift m here or divide by m. Shifting m here, it will become 2k over m is equal to v square. We are interested simply v, not v square, simply v, taking square root both sides. We have 2 times k over m is equal to v square. Square and root cancel. So we have v is equal to 2 times k over m. 2 times k over m. It is a simple way to solve for m, to solve for v, Mostly in Europe, in America, especially it is a style of subcontinent. How foreigners solve this one? That is, look at this, kinetic energy is equal to 1 upon 2 mv square. They say that to get rid of 2, multiply by 2. Multiply by 2. It will become 2 times k is equal to 2 times 1 over 2 mv square. Cancelled out. We have 2k is equal to mv square. Now we want to get rid of this m. They say divide by m. Divide by m, like this. 2k over m is equal to mv square over m. Cancelled out. We have 2k over m is equal to v square. To get rid of this square, taking square root both sides, we have 2k divided by m is equal to v square. Square root cancel. So root 2k over m is equal to v, Same. The style is different. Both approaches are same. Foreigners adopt this strategy. Our subcontinent, 2 in division, shift here in multiplication, m is in multiplication, shift here in division, to get rid of square, taking square root both sides. And it is our v in terms of k and m. It's our v in terms of k and m. Our option B is the right option. Moving towards next question, we have given if the function f of x is equal to x square plus 3 over all 2x, where x does not equal to 0, what is the value of f of 6? We have given f of x is equal to x square plus 3 2x, where x does not equal to 0. We are asked to find f of 6. Let me shed some light on this. X does not equal to 0. Look at this function. F of x is equal to x square plus 3 divided by 2x. This function has a hole. discontinuity at x is equal to 0, discontinuity at x is equal to 0. Or you can simply say that we cannot afford x is equal to 0 here to be put. 2 times 0 is 0, and in mathematics division with 0 is not allowed. It has been excluded. That's why there has been mentioned that x is not equal to 0. It is a restriction. Or simply this function has domain all real numbers excluding 0. We cannot afford 0 to plug in here. That's the science behind writing this x does not equal to 0. Mostly students ignore this, but it is a wonderful concept, wonderful concept. You must be familiar. Denominator does not vanish under any condition in mathematics. In square root, if you are dealing with real valued function, in square root we cannot afford negative values, and log is defined for positive values, and log is also defined for positive values. We have to take care of these three things while solving domain of a function. That is not the case here. However, x does not equal to 0 has been mentioned here. I am compelled to explain this. Okay, f of 6 means we are asked to find function value at x is equal to 6. Function value at x is equal to 6. Instead of x, plug in here 6, f of 6. Instead of x 6 square same plus 3, 2 times 6. Simplify. 6 square means 36 plus 3, 2 times 6 is 12. It will become 39 over 12. Make them relatively prime. Co-prime. Table is applicable. That is the definition of rational number. They must be relatively prime. Applying table of 3, 1 times, and here it is 4 times. 1 3 is 3, 3 3 is 9. Now we can assume that it is our answer because it is a rational number, because they are relatively prime. 13 and 4 have no common factor except 1. 13 and 4 have no common factor except x is equal to 1. That is our answer. Leaving here is something ridiculous. That's your answer. If simplification is possible, keep it up. Always write a rational number in relatively prime form. They have no common factor except x is equal to 1. F of x is equal to x square plus 3x. Look at this. Here we have f of x, and here f of 6. Instead of x we have 6. Simply we have to replace x is equal to 6 in the function. That we have done. X means 6 square plus 32 times 6. 6 square 36 plus 3 39, and 13 upon 4 is our answer. Right option is D in that case. Moving towards next question, we have a good question, a wonderful question. Both they are related. If you take notice of that thing, x does not equal to 0, and here you are going to get good idea about the domain. We have square root a square minus 2a. Given that a is a positive, what is the least possible value of a that would allow for a real value for the above expression? Here you are familiar. Square root of -1 is equal to I, or it can be written as J operator. Mostly we write I. It's our complex number, imaginary part, complex number. Whenever it is present, it is complex number. What is the drawback of complex numbers? We have given 2 plus 3 iota, or say suppose 3 minus 4 iota. We are not in a position to decide whether 2 plus 3 iota is greater than 3 minus 4 iota, or 3 minus 4 iota is greater than 2 plus 3 iota. Order relation doesn't exist in set of complex number. Order relation doesn't exist in set of complex number. Order relation doesn't exist in set of complex number. That is the flaw of the complex number. Flaw, drawback, weak point, Achilles heel of complex number. We cannot judge whether it is less or greater. Order relation does not define in set of complex number. Order relation does not define in set of complex number. What is iota? What is complex number? Any number in the square root having -1 times, might be -1, -2 times, -3, whatever the case is. If you square root -1, then it's known as complex number, imaginary part, complex number. We are here interested in the real value, When we are going to have real value, what we have given? A square minus 2. If it is less than 0, it's complex. We are asked to find a real value. So for real value a square minus 2a, it might be greater than or equal to 0. Greater than or equal to 0. If it is 0 and square root of 0 is 0, it is safe to conclude that it's a real value. If it is greater than, greater than 0, we are going to get some value. Let's see and find out. A square is greater than or equal to 2a. We have a is greater than or equal to 2a. So all the numbers from 2 including 2 towards right, they give us a real value for this. If you put 1 here, 1 minus 2, it is a iota, it's complex number, root minus 1. If you take 2 square minus 2 times 2, 4, 4 minus 4, 0, 0 is a real number, good, and so on. You can safely take all numbers 2 and more than 2, 2 and more than 2. This function is entitled to have real values. We are asked to find the least possible value, So the least possible value is our starting point. A is equal to, the rest is greater than 2. It has two parts. A is greater than 2, A is equal to 2. This is our least value of A. That will give us a real solution. Put 2 here, it will become 2 square minus 2. 2 square minus 2 times 2, we have 4 minus 4, square root 0, 0. It's a real value. So what we have learnt, and same is the idea behind the domain of this function. A square minus 2a plus, it must be 0 or greater than 0. In order to get real value. Same is this strategy. A square minus 2a greater than 0. Solving for a, we have a is greater than or equal to, means from 2 we travel in rightward direction. All these things have been included in the domain. So we write the domain of this function as half closed interval from 2 to positive infinity. That is the domain of this function. Moving towards next question we have for the system of inequalities, we have given some two inequalities. Y is less than or equal to x plus 2 and y is less than or equal to minus x plus 4. When y is at greatest, so we are asked to find corresponding value of x. When y is greatest in these two inequalities, we are asked to find what is corresponding value of x. Let open this up inequality. It is y less than x plus 2 or y is equal to x plus 2. Look at this. Less than or equal to, I can write this as. Similarly, let me open this up as y is less than minus x plus 4 or y is equal to negative x plus 4. We are asked to find its greatest value. Taking y is equal to y, it gives us x plus 2 and other value of y is minus x plus 4. Solve for x, shift x one side, constant on the other, we have x plus x, 4 minus 2. 2x is equal to 2. So x is equal to 2 over 2, x is equal to 1. X is equal to 1 is the value corresponding to the max value of y. Look, if you plug in the value of x here, it will give us y is equal to 1 plus 2, 3, and here minus 1 plus 4, it's also equal to 3. If you plot these inequalities, taking x and y intercept, put x is equal to 0, we are going to get y2. Similarly, x is negative 2 here, and y is 2 in that case. That is the graph of this inequality, as it is less than. Similarly, for other, putting x is equal to 0, we have y is equal to 4. 1, 2, 3, 4. And if we put x is equal, y is equal to 0, we are going to get x is equal to 4. 1, 2, 3. X is equal to 4. So for this is the max value. This is the max value that will give us x is equal to 1. That will give us x is equal to 1. That will give us x is equal to 1. I have split the inequality as y is less than x plus 2 and y is equal to x plus 2. Y is less than minus x plus 4 or y is equal to minus x plus 4. Keeping y is equal to y. Solving for y. I have written y is equal to y. It gave me x is equal to 1. X is equal to 1. Look, y less than x plus 2, y less than. I have taken y is equal to. That is the max value for y. That it will give us max value of y. It is also max value of y because y is equal to in that case. In that case, y is less than this. In that case, y is less than. We are asked to find max value. I have taken the upper portion of the inequality, less than or equal to. I have taken equal to. It give me max value for y. So we solved. We have x is equal to 1. Plugging in here and verifying that y is equal to 3 in that case. Y is equal to 3 in that case. That is the max of these both of these inequalities. And corresponding to max value of y, greatest value of y, we have x is equal to 1. X is equal to 1. Thanks for watching. See you next frame.